Welcome back to the REVan channel. I'm REVan, and with me is Brian Wolfe. And today we're going to be talking engines as usual, Godzilla engines, but not supercharged, not turbocharged, and not nitrous. Today is all about NA power. We're going to have some fun. Brian finally put together one of his NA packages. We're excited to tell you about it. So, Brian, let's get right into it.
Absolutely. So what we wanted to do this year was we wanted to kind of do a high effort NA build. And I don't want to call it a max effort because if we're doing max effort, then we would have gone even a little bit further with some of the items. But we wanted to do something that would, throw up a pretty impressive number, dealing with the stock parts. Because, being a Ford guy that's raced for many, many years, I've raced a lot of Ford engines, but they didn't have one Ford part in them. When I was racing a small block NA motor, aftermarket block, aftermarket heads, aftermarket everything. So it's fun to work with some of the stock parts. Now, of course, as we go through the build, you'll see it has a lot of aftermarket parts in it as well. But it's super cool to me to be working with parts that came out of a Super Duty truck, including the cylinder head casting, and making some, I think, pretty impressive numbers with that.
So before we get into the engine, let me take a second to thank everybody who has subscribed to the channel. We really appreciate you. If you haven't done so, please go down into that corner, hit the subscribe button, leave a comment. Whenever we do one of these tech talks, we get a lot of questions, and we're pretty good about answering almost every single one of them. We do go on there for, especially when a video goes live, the first couple of days, we're really interacting with the questions. So hit the like button, leave a comment. We want to know what you guys think. Brian, let's get into it. 472 cubic inches of Godzilla.
Yes, sir. So the way we accomplish that, I think everybody knows that the Godzilla out of the factory is 445 cubic inches. That's with a stock 4.22 bore and a 3.98 stroke. So what we did with this engine is we took the stock crankshaft down to our friends at Shaft Tech, and we had them offset grind and put a Honda rod journal on it and increase the stroke. Now, the reason I did that is it does, to me, the bore and the breathing capability of the cylinder head system kind of define the power, and the stroke defines what RPM that power will be peaked at. But the other advantage of a higher stroke and the higher displacement is it gives you a higher compression ratio with the same combustion chamber and same piston. So there's a secondary effect to me to increasing the stroke when you're trying to get a high compression application and not put a real ugly dome on the piston, which we didn't want to do with this one.
Now, why would you not want to go with a dome?
I believe, and again, it's always debatable, and I'm sure people will, throw up different cases that will prove what I'm going to say wrong. But I like a nice, clean flame travel. And as you put domes in, that flame has to go up and down through the piston, and it actually can put more heat into the piston as opposed to more heat into pushing the piston down. So with our goal here was we wanted to get 15-to-1 compression with a flat top piston. We ended up at about 14-to-1. So again, high effort, not max effort.
Right. So bore and stroke, how much bigger is the bore than stock?
So this is a 4.25 stroke, 4.25 inches, and the stroke is 4.165.
Gotcha.
And it
Now,
has a Honda rod journal on it.
the burning question everybody wants to know is how much power it made, which, we obviously put it on the dyno and you ran the thing. Now, you didn't go all out with it, right? You just made a couple of initial pulls.
Yeah, this is more of a status video because at the beginning of the year we set two goals at Willis Performance. One was to prove that the stock block, stock cylinder head casting, stock crank could run a 6-second quarter mile, and the other was to build a higher output in a application. So the year is almost to an end, and I'm kind of running out of time with PRI, Christmas coming up, doing some other things with family and stuff. So we had a little time this week to run it, so we didn't change cam timing, didn't do any lash work, just try to get the calibration reasonably close. we ended up with 973 horsepower at 8,200 RPM. So we're pretty happy with that. I think once we dial in the cam timing and also go from a Q16 fuel to a C45, I think we're going to be real close, if not at 4-digit horsepower naturally aspirated.
Now, you mentioned 8,200. How high do you think you'll end up taking it? Nine?
Close, yeah. Probably, I think when we're done, it'll be somewhere 88 to 9,000.
Wow. But not bad for 14 to 1 compared to, say, if you went 15 to 1, if you went, um, you know, obviously there's no aftermarket head yet. So you're still working within the confines of real true OE parts.
Yeah, exactly. And there are diminishing returns. Like when you go from 8 to 9 is a lot more percent benefit than you're going from 14 to 15. But I think there is still a benefit going from 14 to 15 and probably even up to 16. Kind of beyond that, it's kind of diminishing returns.
Right. So let's get into the build, Brian, because I think it's important to talk about what components you used and some of the theory behind why you picked things like aluminum rods and how do you design the piston? Is a raised up ringland and things like that. So why don't we start with the block foundation of any motor and we'll build it out from there and tell everybody what you did.
Okay, so trying to be as efficient as possible with the build, starting with the block. This is the same block that we originally ran 4 years ago that we had in the black car originally. So we reused that block to save some money. And that block was prepped by Dave Petit, my local machine guy, does a wonderful job for me. It has Jessel keyed lifters, so he bushed the block to put those so we could use the keyed lifters. It has roller cam bearings in it. And other than that, it's in the block is half filled. So it still has water in the block, but a reduced water capacity. So that's the block, 4 1/4 bore. I guess if we want to move out from the block, let's go like to the pistons. Maybe that's kind of in. And the piston is a diamond billet piston, super light, 0.7 millimeter top, 0.0 millimeter second, and a 2 millimeter oil ring. It's not, again, max effort, so we have an 866 pin. Other guys probably would be going to even a smaller pin than that. We go to an aluminum rod, and in a motor like this, higher revving, we like the aluminum rods, but also with the custom stroke and custom configuration, it's pretty efficient cost-wise to do an aluminum rod as opposed to asking for a one-off steel rod to be made. So then going to the crank, we already talked about that, offset ground with the Honda rod journal on it. And then oiling system. On most of the stuff we do, we have the daily dry on, the higher output applications, whether it's the supercharged or the NA. We use the daily dry sump on that, and we use the Jessel belt drive as well. That makes it pretty easy, to change cam timing on the dyno with that belt drive on it.
Right.
Going up to really where the big power is being made is the cylinder heads, obviously. And I would call Dave Visner did the heads, as he does all of our cylinder heads. These what I would call stage 3 plus, because they're beyond the stage 3 work that we'd normally do. And taking it to moving the ports up a tad, filling the bottom a little bit, and getting it as far as we can without getting into water, which is very difficult with the stock head castings because they have so much water in them because it is a truck head that does need a lot of cooling. And those long trips towing 27,000 pounds with your Super Duty. So it's got a titanium intake and exhaust valves with it, and of course Jessel rocker arms. It has Dave Visner's rocker stand system in it. And the mat and push rods as well. So titanium retainers, but steel keepers. Again, because with this long stroke, this isn't going to be a 10,000 RPM motor. It's going to, it's like you said, maybe 9. So that talks about where the power, that portion of the powers come from. And then, of course, the other thing is it has that classic design Visner engine development billet intake manifold on it, which is very distinctive, and you see it on many of the high performance Pro Mods, LDR, Pro 275 cars like that that are really need the ultimate in intake manifold performance.
Right.
And we go to a Nick Williams 102 millimeter drive-by-wire throttle body.
If you were going for max cubic inch, what do you figure, based on your knowledge, would be the max bore and stroke or displacement on a Godzilla?
Well, again, I like to stay within the stock crankshaft if at all possible, just from a cost perspective. Because aftermarket cranks and their low volumes on the Godzillas, so they're not coming out of China, thousands at a time. So this is about as far as you can go with a stock crank. With an aftermarket, you can go 400 or 500. Is available. And it's going to take you north of 500 cubic inches. And what that will do is it'll make, I think, very similar power, but at lower RPM. But then the other advantage is, if we had that much displacement in it, we might be closer to the 15-to-1, everything else being equal. So that might be a bit of an advantage.
So Brian, solid roller camshaft, right? That's the only way to go with a combo like this?
Yeah, absolutely. I did talk about the Jessel Key lifters, and I skipped right over the Charlie Westcott Militia Racing Products camshaft. For all my mechanical roller applications, I go to Charlie. Charlie's a wealth of knowledge, super helpful guy and smart. And he's somebody that you can go to and you can talk about what the cylinder head flow capability is. You can talk about what RPM range you think you're going to be able to run with that. And you kind of go in with, well, here's what I'm kind of thinking about, where I want the exhaust valve to close roughly, where I want the exhaust valve to open, where I want the intake valve to close, and then what type of duration we're going to need to get that volumetric efficiency in, get the exhaust charge out. That kind of then defines where your overlap and your lobe separation angle is. And, Charlie takes it from there. It's all his lobe profiles, for what you're doing. Of course, when you go high output NA, you really do stress those valve springs, pretty hard with a mechanical roller at over an inch of lift. So, you're going to have some finite life on those parts. It's not like some of our nice hydraulic roller stuff where you put it in once and forget about it. This is, it's a targeted high RPM, high specific output engine.
Right. And it's a truck engine that's designed to spin 6,000 RPM from the factory, and now you're taking it well above that. Did you notice any challenges in the valve train other than the typical race stuff when you're taking a production engine and kind of going racing?
It's really, the entire kind of stock valve train is gone, right? Because we the stock rocker arms are gone. We've got the shaft mounted rockers, the rocker stands in there. So it's kind of a total different environment than the stock stuff. So for sure.
Right, but I guess the architecture is still there as far as placement of the valve spring. You're not moving where the valve spring is, or the valves in the heads or anything like that, right? To change the angles right now. It's all standard location.
Though, yeah, none of that was changed on these stock heads, for sure. But the valve train itself, the rigidity, and it is a lot different, a lot stiffer than what it would be with the stock application.
Right. So then, did it perform on the dyno the way you expected? And then again, I know you only made a handful of pulls, so you didn't get into the tuning of it. Also, if you could mention what EFI system you used.
Sure. Yeah, I was going to go into that, so thank you. So, yeah, we got the air fuel about where we wanted, a little on the safe side. We didn't go as aggressive as possible, get the last 3 or 4 horsepower. Same thing with spark, but we got a tune in the ECU that we're confident in, that we can do some other development, like on if we want to do valve lash loops, or if we want to do and we do want to do, and we will do, modify the cam timing. I think if we retarded it a little bit, that may help us a bit more. But no, it came out good. I was pretty pleased with doing the first pull we did on it was, I think I did a 4,000 to 6,000 just to make sure that the calibration was close. And then then I think we did a 5 to 8 so we could see where the torque peak was. And then after that, is where we really started to tune where we got, started to do the pull beyond the power peak. Because with these real skinny rings, and if you get into any detonation at all, it's not very forgiving. But we use everything I do on my dyno development is with the OBR control system. Oli is local. He's there to support. So if I need anything special, and the system is super flexible and super capable of doing anything that I need to do on the dyno. So that works out extremely well for me.
Right. Did you run a vacuum pump on it?
Well, I did not run a extra vacuum pump, but the dry sump has a sixth stage, if you will. So there's four suction stages, one for each of the piston, crankcase sections within the block. So there's four suction stages there. Then there's a pressure stage up front to supply the pressurized oil to the system, and then at the back there is a vacuum pump within that daily. But not a high suction like Moroso type pump on it, just through the daily dry sump.
Right. But you're
So
pulling a crankcase vacuum though, for sure.
it's definitely pulling a vacuum, but not a high, not a super high vacuum.
Is that
I don't
something,
have it.
is that something you would add at a later date? Because that should be horsepower, right?
Oh, it'd definitely be horsepower, but I'd say if we don't make it to, if we fall short of four digits, then then we'll be looking to say, okay, do we do a different cam profile? Do we throw a vacuum pump on it? What do we do? Because again, it's if it was a max effort, I would have ordered 3 or maybe 4 different camshafts so I could run them through them one after another.
Right.
In this case, we took our best shot and we're to start. And again, we'd like to see, a 4-digit horsepower naturally aspirated with those stock cylinder heads and block and crankshaft.
Is there any chance any other Ford engine makes anywhere near this kind of power with a stock crank, block, and heads?
Not that I'm aware of. I mean, I guess if I'd have to really, think I don't, like some of the work that Ray Paquette's done on the 427 Super Stock. But I don't know if he runs the Ford castings. He might run an aftermarket head on that now. But that would be one that, is probably makes some pretty stout power. But again, probably all the stock parts are out of it because it's so old and, NHRA allows you to supersede. So that's one that would come to mind that I'd say, I don't know, maybe. And then, obviously, one would have to look at a Boss 429 if someone did a similar, max, high effort, or max effort on that, what that could do. But I haven't seen any, that have done those numbers.
Right.
Again, both those are big blocks, and this is a small block. So if I go to like Cleveland, which would be the highest, which would be the best candidate to do something like this, I don't think so. Yeah, there's some epoxy to raise the intake ports, and we did weld on the chamber to make the chamber smaller, so we could get that compression with the flat top piston.
Gotcha. So explain what you did there, because that's kind of interesting.
Yeah, I don't have any photos of that, but basically, what Dave did again, he's the guy that does all the smart work and hard work. I just get to have the fun of putting them together and running my dyno. But basically, it is just welding of the combustion chamber, itself before, because you don't have valve seats and stuff in it, and then shaping that with the CNC cutters, and bring that chamber volume down.
Oh, that's cool, man. It's all that tech stuff is so interesting. I love engine building, and there's just something special about doing it NA because every little bit matters. It's not just turn up the timing, turn up the boost. Of course, that's impressive stuff too. You're making 17, 1800 horsepower with your Godzilla. But this puts, every little thing matters, the camshaft. And I bet you cannot wait to try more stuff on this engine. What's the future hold for this thing?
Yeah, so I don't know. I'm hoping we can run it more before the end of the year. I just don't know if that's going to be the case. But as soon as I can, dedicate like 3 or 4 days in a row where I can actually, run it on the dyno and do some, development exercise. We're going to run it. We're going to try to get, a 4-digit horsepower on it. And again, I do it, for 2 reasons. being a retired Ford guy, always, I always love Ford. I don't like some of the things the company does, but I'll always love the company. It's fun to still, if you will, polish the oval, as we would say, to show, the capability of the new products, which I enjoy doing. But that's, really the goal. And I'm sure there's going to be other guys that are going to come along, and make, more power than we did. But again, it's kind of, motivation to the engine build team, the Ford guys out there to, to push the boundaries even further. But you got to show them that, hey, this is a platform worth looking at, and you guys ought to be putting some time into it.
Yeah, and the Godzilla movement is moving. It's growing. There's people into it. There's Facebook pages for it and Instagram pages. There's companies dedicated to the parts, just like yourself. And it just add another great engine to the Ford lineup. And speaking of great engines and cars, Brian, that shirt you're wearing, I can only see the top of it, but that's pretty
Okay.
cool. Is that the '08 shirt, the '08 Cobra
It
Jet shirt?
is. Yep.
That's awesome.
Yeah, that was great. But and to your point, like on having great engines, if you're a Ford performance enthusiast, why we don't have the car lineup like we muscle cars like we line up like we had in the '60s, where you had Fairlanes and uh, Torinos and Mustangs and Galaxies. We have one muscle car left, so there's an engine in that, and that is a super fantastic engine, one of the best Ford has ever made. The Coyote 4 valve. There isn't much on the planet that can compete. As I always say, how many engines make 100 horsepower per liter, and the only maintenance on it is an oil change every 10,000 miles. That's pretty cool. But then, we also have this great truck engine that we can, retrofit into resto mods and, with very, very little work, 675 to 700 horsepower, 640, 650 foot-pounds, hydraulic roller, reasonable compression. You throw that in your older Ford and drive around and have a great time. So super versatile. And we got two great platforms that are currently in production to choose from.
Oh, no doubt about it. And inevitably, we always get the comment from somebody, why don't you just put a 427 Windsor in it? Or why don't you do a Coyote with a blower? Or why don't you this? And LS will make this. Frankly, it's about the challenge. It's about the fun. It's about learning. It's about the excitement of something new. There's always somebody faster. There's always somebody with more horsepower, more money, whatever. This is about the fun we're having with this project, and it's been great so far.
Yeah, absolutely. Like I said, it's all about, pushing the envelope and encouraging others to do the same.
Yeah, so I mean that's all that's what it's all about, right, Brian? It's just, learning, having fun, educating yourself, trying something new. Not everything is a success, but the real mistake is not learning from your mistake. It's okay to make
Yeah,
mistakes.
or if you didn't try, you've already failed.
Yeah, there's a million cliche sayings. I love a lot of them. I quote a lot of them. But man, this has been great having you on the channel again. Brian has been a huge part of the REVan channel and will continue to do so. The last video we did, if you missed it, was on Brian's 6 second run. Another congratulations to Brian. He went the first 6 second pass with a Godzilla recently. So we did a video on that. You can go back and watch that. You probably see him wearing the REVan hat and shirt. We had a bunch of people after the last video reach out about how they can get a hold of some stuff. So drop a comment if you're interested. We'll get you hooked up. Brian, thank you so much for being on the channel. You have anything else to add?
Nope, I just appreciate everybody's interest, and I hope you guys are excited as Evan and I are about the Godzilla and other Ford performance products that are available. And like I said, 2025 looks like it's going to be a fantastic year. Future looks bright for performance industry.
Yep, we're going to head out. Hope you guys have a great night. The new year is coming. 2025 is going to be a good one. So thank you for watching the REVan channel and hope you come back for more.